Okay, so good morning, good evening, good afternoon. Welcome to another class. So today we'll be looking at statistics, concepts in statistics and probabilities on GeoGebra. So the first thing I'll be looking at is statistics. Looking at mode, mean, median, the basic concept of statistics. So what you do is we look at a question first, or not even a question, just a list of numbers over here. So some raw data, as one would say. So I'll just copy it onto this. And with this, I will not need the graphics, please. I'll only be dealing with the algebra for now. I'll only be dealing with algebra. So what I'll do is I'll go to view. I want the keyboard here. On the keyboard because I would like to get the curly bracket from the keyboard. Then I place my numbers over here. I place it. Enter. So what GeoGebra does is it gives me the list. The numbers are inputted. It gives me the list. Then I can see the length of length. But first, let me assign it to, let's say, n, small n. So n is equal to then length of object. So the object is L1. So the n being equal to 32 is showing us the number of elements in this. So 45 is 1, 2, 3, 50, like that. So we have 32. You can also find the mode using GeoGebra. So we all know that the mode is the most occurring number. The most occurring number is the mode. You can also find the mode. So mode, then is equal to mode. List of numbers. L1 is the list of numbers. So our mode is 55. So this is telling us that the most occurring number here is 55. You can see 55. Occurring number 55. 1 here, 2, 3, 4, 5. It appears 5 times. So 55 is the most occurring number. You can also look at the median. So the median here is the middle number. So when you arrange it in ascending or descending order, the number that appears in the middle is the median. So here, median, list of numbers, L1. The median is 7.2. So now, the reason why the median here is 7.2 is because when it means you are not getting a clear number. It means it was not a clear number, it was two numbers. Since n here is even, that is why we are getting this. Since n is even, it means you are getting two numbers in the middle. Two numbers as our middle numbers. Then you add these two numbers and divide by 2. That's why you are getting 72.5. So if n were to be odd and you arrange it, you get a single number as your median. But since n is even, that is what happens. Since n is even, you are getting this. And this is for raw data. Now, after we find the mode and the median, you can also find one thing, which is the mean. Now, the mean. Sorry, I want to write something. Let's highlight it in the graphics view. Right. A minute. Let me just. Hang on, let's highlight it in the graphics view. So So we know one thing about the mean. The formula for the mean is mean equal to. So we know what we've been doing, sigma f x over sigma f. So with this formula, sigma fx over sigma f for the mean, this is when you have your frequency distribution table. When you have a frequency distribution table, you get your f, and you get your f, and your x will be the data. So now here we don't have a frequency distribution table here. We just have the raw data. I want to find the mean. Okay, you have the raw data. I want to find the mean. So it's the same thing. This sigma f is just saying the total number of when you multiply the frequency by its corresponding x value, then the total number of the frequency. But since we don't have the frequency, the other way we can find the mean will be equal to, the mean will be equal to sigma x all over n. So this is for the raw data. So you add everything and divide by the n. That's the number of variables in there. Sorry, the number of elements inside the list right now. So the sigma x is, so when we add, or sorry, when we sum, so the sum of L1. So we have a, this is the sum of L1. Now, since I don't need these ones anymore, I can delete them. But we've seen that sigma fx is equal to, the mean is sigma f x over sigma f. If it's, you have a frequency distribution table, but if you don't, you can just go with the raw data, sigma x over n with the raw data. Now I'm just deleting. Okay, well, what we have here is our sum of the elements, or of the numbers, sorry. Then you can find our mean by, so our mean will be equal to a divided by n. This would be our mean. So a divided by n. You can also just type mean in our input bar, then L1. Sorry, it's like they found the mean for all. So you can also find our mean by just typing the mean in the list of raw data, L1. So this is our mean, 72.06. This means that when we add everything here and divide by 32, so 2,306 divided by 32 is giving us this. Let me rename it as mean. I'm saying cancel. If we also do this, we are supposed to get the same answer. To do A, which is 2306 divided by 32. We are still getting 72.06, which is the mean. So the mean is also the sigma x divided by n, which we've seen over here. You can also get variance or our standard deviation first. So let me get our standard. Sorry, let's get our variance. So we can get the variance from here. Now, if you have our variance, we know that variance is equal to standard deviation squared. So when you square the standard deviation, you get your variance. But now that we just have our variance, what to do to get our standard deviation is we square root the variance. So the square root of the variance. So we square root the variance. A minute, I'm coming. Root of the variance would give us the standard deviation. Minute, I'm looking for minutes. I'm looking for so what I was saying is right now the B is our standard deviation, sorry, our variance. Now to get our standard deviation, we can do ST, which is the standard deviation, then equal to square root to SQ UR. So SQ, so SQ, so I would say SQRT. Then is the square root. Then we input the B here. So this is the standard deviation of it. You can also find just the deviation. But before that, let's confirm if what we have here is the correct thing. So we can confirm if everything we have here is correct by going to view and going to spreadsheet. So now I'll just go and copy again the list of this is the list. Now I'll highlight it here. Then let me just increase this. Once I highlight, I'll come here and I'll click on analyze. Once I click on analyze, I get this. So it can draw a histogram for us to then here. This is what I wanted to show. Statistics list. So now you can see our mean our n is 32, our mean 72.06. 0.06 as we had here. Our standard deviation 15.7 there. Our variance is also here. Then this is just confirming what we have, our maximum. Then you can also get the range, the median 72.5. As you also said, the minimum 45. And here too, we can look at the graphs. I have a histogram, bar chart, box plot, stem and leaf plot. As we are there, so the stem and leaf plot, you can see. So here is this is the key, this is the mean. So 4, 5, this is 45, 50, 52, 55, 55, 55, 55, 55, 8. So with the stem and leaf plot is another way in which you can find the mode also simple, because you see 55, 55, 55, 55, 55, simple. You can find it very simple. Now, the next thing we are going to look at is the probability. So I just go here, click on probability. It will take a bit of time then to come. So now this is what we have. So the probability, GeoGebra has done everything here already. So this is a normal distribution curve. So you can see that the normal distribution curve, one of its properties is that it is symmetric. The normal distribution curve is symmetric. So with this, it has the mean of 0 and standard deviation of 1. So you can see here, the mean is 0. The standard deviation is 1. So standard deviation, how far away is from the mean? That's what we're trying to see. Then see, because it is 1, 1 to the left side, 1 to the right side, and the range is between -1 and 1. That the standard deviation is 1. And the probability of getting, this is the probability, the P here, probability of getting a variable that lies between -1 and 1 is 0.6827. So, which is like 68%. So this is the probability of getting a variable x in between, of getting a variable x here, 68%. Then we can also change the parameters. You can say two standard deviations of the mean. So with this, it's just one standard deviation of the mean. You can also get 2 standard deviations of the mean. Enter. When you have 2 standard deviations of the mean, you can see that here the probability changes. The probability of us getting a variable here in this curve is 0.95. The probability changes. Also, we can change it to the parameter to 3. And see this way. So when you change it to 3, the probability goes to 99%. So 99.73%, which shows here we can actually see that. So with this probability of us getting, well, in this blue range, the value of x in this blue range is very, very likely. That's where the probability is, around this side. So we can go back to its original one. Now, 1. Now, this is what we have. So we can also get other distributions. The chi-squared, exponential, binomial. So now we also look at the binomial distribution over here. Where we have. So with the binomial distribution, you can see a mean of 10 in the standard deviation of 2.23. Then the probability. So x is ranging from 8 to 12. 8 to 12. X is ranging from 8 to 12. And with that, probability of us getting is 0.7. You see. So here is the mean. And we can see that the standard deviation is 2.2. So it's how far away is it from the mean? So 2. So you can see from here to here, it will give us like 1, then another 1, then some point here. So we are getting 2.284. Because there's no grade, we cannot see the lines form. So class, today we've looked at statistics and also we've looked at some probabilities. The statistics, we looked at mean, mode, standard deviation, variance, and now we are looking at some distribution. But before we go, I just want us to see the normal distribution. You can go here, right click, then copy to graphics view. Then we go to our graphic view here. We go to graphics view. When we go to graphics view, we can see. Let me go to view again. Let me do the algebra. Then I name the grid. Minutes. I just want to make it clear. So this is what we have. You can see our normal distribution curve. Now you can also see the function of the normal distribution, which is over here. So e to the power minus x minus into bracket x minus 0 square all over 1 square times 2, then absolute value of 1 root of 2 pi. Now this is what we have. Thank you, class. See you another time.